Hello, my name is Agustin Calixto Ramos Solano, and I will present my work entitled XPS Characterization of ALD-Deposited Aluminum Oxide Thin Films on Silicon Substrates, which was carried out at the Laboratory of Processing and Characterization of Nanofilms at Simestap, Querétaro unit. Let us begin with the introduction. Thin films of aluminum oxide are widely used in electronics due to their excellent electrical insulation properties. To achieve greater control over their performance, it's necessary to have a precise understanding of their composition and thickness. This work employs X-ray photoelectron spectroscopy to analyze films grown by atomic layer deposition on silicon wafers. By applying the multilayer model, we estimate both composition and thickness, which helps us to optimize their properties for device application. Substrate clean. Now I will explain the substrate preparation process. We use the RCA cleaning process to remove any contaminant that could affect the characterization. First, the substrate was cleaned in a solvent sequence: acetone, isopropanol, and methanol, using an ultrasonic bath for 10 minutes. Then it was placed in a Perana solution with a ratio of 5:1 for 50 minutes at 70 Celsius degree. Next, the substrate was treated with RCA1 solution with a ratio of 1:5:1 for the same time and temperature. After that, it was treated with RCA2 solution with a ratio of 5:1 under the same condition. Finally, the substrate was dipped in a HF solution with a ratio of 7:1 for 2 minutes at room temperature. Sample preparation. For the LAD ground, we first perform an initial purge. Then we apply pulses of 21 milliseconds for TMA and 15.5 milliseconds for water, with a purge time of 15 seconds for both TMA and water, and this process was repeated 20 cycles. XPS characterization. From the deposited sample, we first obtain the XPS spectra, then perform peak finning, and finally carry out the assessment of chemical composition and film thickness using the multilayer model. Results. As results, we obtain 4 spectra: silicon 2P, aluminum 2P, oxide 1s, and carbon 1s, each with its corresponding peak finning. By applying the multilayer model, we obtain 4 equations according to the proposed physical model, obtaining the following values for film thickness and chemical composition. Conclusion. The ALD deposition parameters prove effective for achieving aluminum oxide grown on the silicon substrate. Spectral feeding with an analyzer using advanced background models successfully reproduces the experimental peaks and The multilayer model provides a reliable estimation of both the sample composition and the thickness of the dim films.